All right, so good morning or good afternoon, whenever you're watching this video. Today, what we're going to be talking about is we're going to be introducing our quadratics unit, okay? So there's a lot of aspects that go into quadratics, and we're just going to start on how we identify different quadratics, okay? So, again, like I said, we're looking at quadratics, okay? And the three different types, or three different ways we're going to see quadratics are equations, tables, and graphs. Okay, we're gonna look at all three of those. So, in order for an equation to be a quadratic, okay, the equation must be equation to the second degree. Okay, and that means that one term is squared. And we're going to see examples of these. Okay, so it's an equation that's to the second degree where one term is squared. Okay. In order for a table to be a quadratic, now this definition is a little bit confusing. So in order for a table to be a quadratic, the difference of differences, and I'll explain this later, the difference of differences of y values must be the same. Okay, so the difference of differences of y values must be the same. Again, we will look at examples of this. Okay, I'm just giving you definitions for now. And then for graphs, they must be in the shape of a parabola, okay? And what that means is it's curved. Okay, so it's gonna be like a U or an upside down U shaped. Okay, but the key word here is curved, okay? We don't want any kind of like jagged lines, okay? And again, we will see examples. So, for our examples, number one, we want to tell whether each function is a quadratic, okay? And we're gonna explain. So let's start with the equations. So number one, I have y plus 5 equals 2x squared, okay? Now, first thing we wanna do is we wanna get that into like our normal form, a slope-intercept form, okay? So, easy steps. We subtract 5, what I do to one side, I do to the other. So I get y equals 2x squared minus 5, right? We always want our equations to be y equals, okay? So, now, looking at this equation, right? We have to ask ourselves, is this equation to the second degree is one term squared? Well, looking at this equation, yes, it is to the second degree, right? Because this term, 2x, is squared, okay? So I can say, yes, it's a quadratic because of 2x squared, right? That the 2x squared makes it a quadratic, okay? Because it's a second degree polynomial, okay? For number two, so I have x plus y equals 13, okay? So again, we want y equals, we want it slope-intercept form. So I draw my line, subtract x, what I do to one side, I do to the other. So I have y, that cancels, equals negative x plus 13, okay? So now I look at this. Is this an equation to the second degree? Is one term squared? Well, looking at this, no. I have negative x, that's just a variable, no, not squared, and then plus 13. That's a constant. So I can say no. I can write not second degree, not second degree. We can say polynomial. Okay, no, it is not a quadratic. Okay, so pretty easy. You look for the squared. If you have a term squared, yes, it's a quadratic. If you don't, no, it's not a quadratic. Okay. So that's equations. Now for tables, okay, so the definition was the difference of differences of y values must be the same, okay? So what that means is, let me draw the table. So we have this table here, right? We want to find the change of the values, okay? So we start with the change of x. So I have 1, 1, 1, 1, right? So they're all the same, okay? Now, if you find the change of y, 3, 5, 7, 9, right? I'm going up 0 to 3 is 3, 3 to 8 is 5, 8 to 15 is 7, 15 to 24 is 9, okay? But what we want to know is that the difference of differences of y values must be the same. So what that means is we take our y values and we go one step further. We find the difference between these. So what I mean is like this. So the difference from 3 to 5, that's 2. The difference from 5 to 7, that's 2. The difference from 7 to 9, that's 2. Okay? So all of these are the same. So that's the difference of differences. So that means this table is a quadratic. So we can say yes, it's a quadratic. It is a quadratic. Okay? And again, it's because the difference of differences of y's is the same. Okay? So you just find the change of y, find the difference from each change of y, and if it's the same, quadratic.